Yes, this talk is going to be in English, so I'm sorry about that. My French in France is not really French, so sorry. Thank you for the presentation. I don't know if you've noticed the tag that I have in the schedule, which is an alien, and this is how I feel here. This is the very first time that I'm presenting to anywhere else but in the geospatial domain where I work. So please be gentle with me. I hope what I'm going to show is going to be interesting, at least for you. And I know that there are a lot of software developers in the room, so maybe, just maybe, I can get you on the other side into the geospatial domain. So the title is quite pretentious, but I promise that I will explain how I got to this long line of words. So a few things about me. I've been in the geospatial community working with open source solutions for various geospatial activities for a very long time, or for a long time, let's say. I am active in the Romanian community because I'm a Romanian. I live in Bucharest. I've been acting also in the international community for geospatial. I am part of the open source for geospatial foundation that I'm going to share a bit more as we go along. And I also work, my day job, I also need a day job. So my day job is in a remote sensing company. I work with Earth observation data, and I lead our initiative in providing scientific services to the insurance and reinsurance sector in Romania and in Europe. I'm basically interested in rapid mapping for disaster management. And for that, I use a lot of open source. So as I've mentioned, my life, my professional work, and what I like to do is basically leaning on two pillars. One is the voluntary work that I do with the foundation I've mentioned, the Open Source for Geospatial Foundation, which is a foundation that was started in 2006. So it has a bit of a history. It is a not-for-profit, is a volunteer foundation, and we rely mostly on a duocracy principle, meaning that if you want something done, then go ahead and do it, and then you will have people joining if they have the same interests. So a lot of the things that are happening in this foundation is done in this way. And I'm also serving my community as a board elected member. This is my third term. I'm not going to go ahead and read, I'm just going to go further. And on the other side, the second pillar is related to the work that I do in the remote sensing field. And the company is a small company, and we are quite close to the scientific community in the sense that a lot of our colleagues are PhD graduates, students, and a lot of the work that we do is related to using Earth observation data in order to better understand our Earth and phenomena that's happening on it. So on these two pillars, actually, I came here today in front of you. But I'm going to talk today about a project that I've started in 2016, not necessarily a project, but an initiative, and it's much closer to my heart than what I've mentioned. So I'm going to start with the last part, with the part of Earth. So I mentioned geospatial a lot of times until now. So you're quite, you got a hint of what I'm going to talk about. I'm sure about it. So what I want to emphasize is the importance of geospatial software, and then I will go to the open source part of this geospatial software in everything that we today know about Earth. And of course, I know you know from school or from other passionate studies that you might have had in this in your life related to how we try to understand our Earth, which is we try to define it in layers that we analyze. We call them spheres, and we look at the atmosphere, and we look at the hydrosphere, and biosphere, geosphere, and so on and so forth. And I know for a fact that in your brain, when you hear something about geography or geology or something that is related to Earth, you automatically think about maps and about geospatial analysis. And that goes, Okay. Nice picture, but I'm going to go through. And actually, that goes to everything that we know about something, or we want to know about something that has an absolute position, meaning it is determined by a pair of coordinates of latitude and longitude, or if it is something that has a relative position against another object or another phenomena. In understanding that, we also use geospatial software, and a lot of it is open source. I saw this morning a very interesting presentation, a very interesting talk, and I'm sure that you thought about when you were looking at those directed graphs and not the actual topic of it, that some beautiful maps and cartography could have been also considered. So, for example, what I'm trying to say here is pinpoint to the fact that there is an important component in this IT world that is related to geospatial, to something that has a place on Earth or relative in our world, and we use it to understand everything. Literally everything. I might be biased because I'm a technical geographer, but I really do believe that if you think about history, you think about maps at some point, right? If you try to understand politics, or should I say geopolitics, or anthropology, everything is connected to a place or is in relation with a place. So this idea of trying to understand our Earth, our world, not necessarily only the physical one, but also what we do around and how we move and how we vote and how we behave, right? Everything has, at some layer, and usually it's a base layer, it has a geospatial analysis, processing, visualization, and so on. So even if you're trying to see here how an iceberg is moving, or if you want to have an understanding of the history of Europe, right, you use a map because it's easier to understand. And this is one piece that I really liked from the New York Times, for example, with respect to what we do here on Earth, right? This is a map of all the undersea cables that are offering our world, that are giving our world an internet connection, right? All the optical cables. So everything that we try to understand, we do it through visual communication. If it is with a position, then we can do maps. And we've been doing this for a very long time, right? I imagine that you recognize this geography, right? We've been doing it for a long time. Now we are doing it in a much more modern way, let's say, but the principles are the same. Everything that we do has a geospatial layer, let's say. This was another one from the Library of Congress that I really liked. It has a lot of information on the side. Everything is open, so you can check it out. This Library of Congress is a real trove. Okay, so everything that I've said so far is actually trying to lead you to towards the idea that what is related to geospatial software is important, because we've seen, I mean, if you're trying to get from A to B, you are using geospatial. If you try to find a good school for your kid, you're going to be using geospatial information, right? So the idea is that this is the reason why I am saying that it is a digital infrastructure that is very important for our understanding of the Earth. So you're probably familiar with this notion of digital infrastructure. In 2016, a fellow from the Ford Foundation, actually she's an economist at the basis, as a background, she defines this digital infrastructures like bits and pieces of code that is used by companies or by individuals, by research centers, by national governments, agency, whatever, to build software, right? And we don't build software just for the love of it, right? Even if we do like it, but we do it because we need a tool in order to evaluate something, to process something, to understand something, right? So this is why it is a digital infrastructure in the same sense that we use roads to go from A to B, or whatever other infrastructure you can think of. And why is it critical? Well, in the open source world for geospatial, the first solution that became openly licensed is actually named GRAS, and is one of the most popular and really fully fledged. It's a mature solution, of course, and it was firstly developed by the US Corps of Engineers. And they have offered it to the public in the sense that they understood its power and they wanted it for it to be further used. And since then, since 1980, that's a long time. That's a really long time. So since 1980, a lot of the digital infrastructure that is used in geospatial software, even if it's proprietary or if it is open source, a lot of it is open source. And there are a lot of very significant, let's say, core libraries that are used across the entire spectrum. So it is critical. Of course, this is one of the solutions that it's so critical for the open source. But going further, I am pretty convinced that you are all very well familiar with what open source means. And you might ask yourself, why is this more important? Why is the geospatial one more important than the open source in general? And why is it different? The reality is it's not different. I mean, it functions under the same paradigm. It is fast. It is very dynamic. It is continually developed by international communities, right? People that probably didn't even meet each other, through their work for a specific software. And an even more important aspect, it is interlinked. And I know that this makes sense in any kind of other domain, but I'm going to talk about the one that I know, about the geospatial one. So how all this work started? Well, in 2016, when I started working for the remote sensing company and I was doing my mapping and other stuff, my CEO came and said, okay, so the company is part of this European Association of Remote Sensing Companies, and they've put out this concept paper. They've found out at some point that there is this open source thing, and they're interested to know if they should be doing something about it. So would you like this task? Do you want to, have some discussion and present what open source is? And at that point, I was a bit younger. I was a bit more cocky on what I know, or I thought I knew. So I said, of course, I can do this. I'm part of the open source community. Before I finished university, I went there. So I'm using them. I use the solution. I know. Little did I know that when you try to explain what open source for geospatial is to people that have nothing to do with code, that have nothing to do necessarily with the actual product that comes out, and they have a lot to do with the commercial side of it, things are becoming significantly more complicated. And in that time, in 2016, the companies in remote sensing, so in the geospatial field, were not necessarily extremely close to the open source paradigm, meaning that they also did business in proprietary software. So bringing in open source was not very, they were not happy, let's say the least. So what I did was trying to understand, how can I explain to these people that open source is valuable? And I knew it was, at least, I was using it, and I was using it well, and I wanted to convey this message. And it wasn't the first, I looked around and see how other people tried to explain what open source for geospatial is. And lucky for me, I come across this report that was done in 2007. There were 3 reports done, which were named the State of Open Source GIS. GIS stands for Geographical Information System. And the guy that was writing this report is Paul Ramsey, is one of the most important people in the geospatial community. I don't want to say only for open source, but in the geospatial community, he's the father of Postgres, which is a database for geospatial data, and is one of the most complete, mature products related to database at this point. So what this guy is doing in 2007, he's defining open source for geospatial. These projects, he's defining them in tribes. He says, okay, this is the C tribe, this is the Java tribe. So these, he sees them a bit like groups in their own work. But he also notice that there are interchanges between these tribes working together, and he understands in 2007 that these are not separate, not completely separate. So what I did, I thought that that was a very good idea, and I thought that, you know, like, I work with maps, so I know that a picture is worth 1,000 words. So, okay, I want to show this to these people that don't believe in open source or are not really interested. So what I did at that point was trying to build a picture of how all of these open source solutions for geospatial looks like. And I started to document with one of my colleagues at that time and put in a Google spreadsheet all the open source solutions we knew about, we knew about, and we would go to conferences, find about it, and so on. And we documented these, but extremely simplistic. And you can see that what we were trying to document on each. And in this documentation, in doing so, even for me, it became clear that the open source for geospatial is a mature ecosystem, meaning that for every process in a cycle that relates to obtaining geospatial data, storing it, processing it, visualizing it, you know, interpreting and information about and getting information about the Earth, doesn't matter the domain, but for each of these steps, there was at least one fully mature, operational, usually, open source solutions. And I did find a lot of agencies, for example, United Nations agencies that were using open source, that were supporting open source, and not only. So it was clear to me that this was a mature environment. And I had a proof behind what I was saying, that licensing is important. I had a proof behind the idea that an open source project, and not only in geospatial, is healthy, let's say, when its governance is transparent, when people that are contributing in a way or another, even if they're writing code, even if they're writing documentation or whatever else, even if they are power users and they're submitting bugs, the healthier the community, the more transparent the governance is of it. And in this kind of documentation that I was doing for the Remote Sensing Association, Companies Association, it became clearer and clearer to me. So, very excited. I went in 2017 to present my conclusion to this board of professional companies. And although the presentation was pretty well received, apparently it did not convince them into trying to better understand this open source for geospatial ecosystem, saying that, okay, it exists, it is there, they're doing their own thing, we don't want to support it in any way. That was not their official answer. They said that they would come again, but since 2017 September, we've had some Septembers and it didn't happen. But one thing that I discovered in doing that was that this was actually quite an interesting tool. And it wasn't only for people like me that were actually working with them, or for coders, or it was more than that. it would have been a good understanding of where this community is. So what we did was to continue to document in that Google spreadsheet and to continue to present wherever I could go, usually to the geospatial conferences that I used to go, and I would also introduce this presentation and so on and so forth. We tried to find funding for what we wanted to do, because the documentation of these projects that we started with was extremely simplistic. So much more we could have known about them and we could have used in understanding how this ecosystem looks like. And the cool part was that in 2023, we managed to convince the European Space Agency to support this initiative into better mapping the entire ecosystem of open source solutions. So this led us to an initial plan. What we wanted to do was to go beyond the simple documentation of what we had and to truly understand the software that is used in geospatial. So we considered the 5 categories that you see on the left that are categories relevant for the geospatial field. And then we considered a series of metadata, if you'd like, on the project itself. And when we did this, we didn't do it on our own. We tried to have informal, and I guess we also had one formal meeting, but a lot of informal meetings with open source people in the geospatial field. People coming from ESA, of course, from NASA, as you've mentioned, Stephen, people coming from the European Commission and OGC, for example. The Open Geospatial Consortium is an international organization that is standardizing the geospatial domain with respect to the format of data and of software. So we defined a series of elements together with these organizations on what exactly we should document, to better understand what we're looking at. And how we are documenting it? Well, of course, in 2 ways. One way is, as you've already probably imagined, we are automatically harvesting the Git repo of each of this solution. But the important part, if you ask me, is related to the documentation that we do, and at this point is done manually with elements that you cannot find in a Git repo and that are important for people that work in the geospatial field. For example, the functionalities of the software itself. If it is for cartography and visualization, if it is for remote sensing analysis, if it is for data management and vector processing. So they're different, and what we've tried to do is to define a series of general functionalities that can be then attributed to each of this software. Okay, so where we are? Okay, yeah. So here is the manually collected data. Of course, the governance model is also something of interest. The standards compliance in geospatial world, like in any other IT-related world, and not only, the software that we use has to be compliant with specific standards. It's a strong word, but if it is compliant, then there is a chance that it will be used more than something that is not compliant. 5 minutes. Okay, going further. Okay, so through this FOSS for GeoObservatory, how we mention it, we see that it has 3 main functions that we are happy about. Let's say we think and we try to offer a complete understanding of what open source for geospatial is, and at a specific point in time. It provides guidance, and you will see why we need guidance into understanding what solution is the best for my problem. In the geospatial domain, as you've seen, there can be a lot of subdomains, even if you're talking about the physical world or if you're talking about social sciences, let's say, world, if you think about history, if you think about something else. So you need to know what solutions to select, what solutions to test. Because like in any other domain, if you're trying to build a service or a product, or if you're doing an analysis, then you need to understand what solutions are best appropriate for it. And it's not an easy task at all. I'll just run through. Okay, all the data is open data. We make it available through an API. So if you're interested in visualizing these kinds of projects, then you're welcome to test it. I will go super fast. Why did I mention that it's not easy to choose the right solution for your project or for your product or for your small company or for your small, I don't know, research thesis? Because I don't know if it is very well seen there, but at this point, since 2016, we have documented in the database, which is openly licensed, as I mentioned, and available through an API, we have documented 551 solutions, geospatial solutions. So I don't want you to think that they all do the same thing, because they don't. They're not all compliant with the same standards. They're not. You need, and doing a geospatial product from one end to another, or a service, I can assure you, one software is not going to be enough. You need something for storage, you need something for processing, you need something for visualization. So they're different. And you need to understand which are the best, because if you're going to spend 1 year investing into learning that software, into improving it, right? If you know a little bit of coding and you want to, I don't know, to add a new module to it or things like that, you need to understand if the open source license is the one license for you. You need to understand if the project that you are adhering to is not, I don't know, a benevolent dictatorship, right? You need to know that there are a lot, you know, like there's a guarantee that your contribution to it is not at some point going to be locked down in some proprietary license and so on and so forth. So this is the link of the project. Why do we do all of this? Well, I kind of mentioned, we are trying to offer a complete overview of what is open source for geospatial. We're trying to build it as in a service more for international institutions that can use this kind of tool in order to understand the level in which open source is today in the geospatial domain. I'm not going to go through that. So what are our plans? What are our plans in the next months? Well, we have big plans. What we're trying to do is that we know that we have a significant database. We have a good material, let's say. And now we are working on defining different metrics, statistics on the database. For example, trying to understand which projects are more active with respect to the number of contributions and to the number of contributors and all kind of stuff like that. What we don't want the FOSS for GeoObservatory to become is some kind of how to call it, like something that gives a grade. We don't want to grade anything. What we want to do is show this ecosystem as it is today. Because another important thing that I don't think I've mentioned is that within this ecosystem, we're also documenting the connections and the dependencies between the core libraries and all kinds of other software projects. So what we're trying to do, we're trying to communicate closer with big institutions and organizations that are using open source. And happily, at this point in life, there are a lot of them. And here are just a few that we've already that we've been trying to talk to. It's not an easy road. I don't know how many of you have tried to close some kind of memorandum of understandings with institutions such as the United Nations, but these are very grinding conversations. And even if I understand the improvement and the good that can come out of it, sometimes it can become tiresome. We're also working on improving the observatory because we want things that could at least be a bit more automized to be. One problem that we have is related to licenses. The important and one of the basic rules in order to be part of the open source ecosystem for geospatial is for your project to be openly licensed. But what we've seen in these 500 projects is that a lot of them do not have a standardized license, or they start with a standardized license, MIT, Apache, or whatever, and then they change. They introduce something that it changes, and that cannot be automatically identified. Why is this important? As I've mentioned, in order to get Earth observation, let's say, service at the end, right? I need to use multiple core libraries, software for visualization, for whatever. And I need to make sure that all of that chain is actually legally interoperable. Because if it is technical, but it's not legal, then I cannot use it, or I should not be using it. As I've mentioned, metrics. And yes, that is it. And thank you very much. Follow us, talk to me. As I've mentioned, I feel kind of an alien here. I hope that you've enjoyed this presentation, and thank you.